Okay, everyone, so as promised, here is the video version of the answer key for the Desmos activity. So the first part here, the first page, actually page 6, asks you to put each quadratic in standard form. And we need to remember that standard form of a quadratic is y equals ax squared plus bx plus c. So here, everything's already on the same side of the equal sign. So I'm just going to move it around so that my x squared term is first, so it's negative 4x squared. And then minus 3x and plus 9. Make sure your signs are correct, right? So we take this sign in front of the term. So this is why it's negative 4x squared, and then the 9 is positive, so that's why plus 9. Here, I want to get y by itself, right? I want y equals, so I'm going to add 7 to both sides, right? Just like solving a regular equation, whatever I do to one side, I have to do to the other, right? And that will cancel this and leave me with y equals. And then I want to put it in the correct form. So again, negative x squared plus 4x plus 7. And then same with part C. There's a couple of ways you could do part C, but honestly the easiest way to do it would be to add x squared to both sides. So get y by itself, add x squared, these will cancel, and you'll be left with y equals x squared minus 8x plus 2. So those are the three rearranged in standard form. The second problem here says answer the question based on the graph given below. So assume this graph continues forever in both directions, which means that I can have arrows here. It says with the leading coefficient, or the a value, so right, we have our y equals ax squared. It's talking about that coefficient in front of x squared, saying, is that positive or negative for this graph? And the answer is negative because the graph opens down. Right, if it opened up, that's like our regular quadratic. Our parent function opens up, so it's positive, and then if we flip it, it opens down, so it's negative. All right, here is that problem that talks about all the different features of a quadratic graph. So coordinates of the turning point. The turning point's right here. You can actually click on it. It is negative 3, 4. Then it talks about over what interval is the graph decreasing. So we read a graph from left to right. So this graph is coming up from the bottom and from the left, and it's increasing until we reach the turning point, right? The turning point is where it's going to change direction, right? So I get to the turning point and then I start to decrease. The graph starts to go down. So from the turning point to forever, it's going to decrease forever on this side of the graph, right? So strictly decreasing on the right side of the graph here. So over what interval, when they ask that, they're referring to x values. That's really important to know that they're talking about x values when they say over what interval. So starting at the turning point, but not including the turning point. Sorry, that's really sloppy. So starting at the turning point, but not including it, the x value of it, so negative 3 to infinity. So you can write it like that, or you can say x is greater than negative 3. Right, and some of you might be wondering, why is it negative infinity if the graph is, or why is it infinity if the graph is going down? Because as we go down, remember we're talking about the x values, and the x values are going to continue to go to the right, and they're going to continue to get bigger. So we're talking about x values, we keep going positive. So what interval is the graph increasing? So this is the left side of our graph. So over here, right, this is where we're increasing. And our x values are coming from the left. So they're coming from negative infinity. So we should have negative infinity until our turning point. So until negative 3, right? This is also x is less than negative 3 to the left of the turning point. Sometimes I know the interval notation is kind of funny, so you might actually like this set notation better because it's pretty literal, right? This is to the right of the turning point. doesn't let me write point, but I'll do it like that. And this is to the left of the turning point. What are the zeros of the function that refers to the x-intercepts? There are two of them here. -5 and -1 are our x-intercepts. So you can write x equals -5, x equals -1, or you can write -5 comma 0 and -1 comma 0. Over what interval is the function positive? So again, it's asking over what interval. So that's talking about x values. So between what x values is the graph positive or above the x-axis? So it is above the x-axis from here to here. So between the x-intercepts, between -5 and -1, not including them, because at those values the graph is 0, hence zeros. Right, so we can also write it like this: -5 is x is between -5 and -1, or we can literally say between x equals -5 and x equals -1, not including those values. So any of those I would take. I know notation is kind of tricky. Try the notation, but if you can't, I'd rather you just explain it instead of leaving it blank. The domain of any quadratic we should be comfortable with is -∞, comma infinity. And the range, this graph comes bottom to top, right, lowest to highest. So we're coming from the bottom to our turning point. So range is the y value, so it's going to come -∞, comma 4, hard bracket, because we're talking about range. And those are those features of the graph. Some more features. So it says the leading coefficient is negative. So that's going to tell us that our graph is opening down. Actually, we'll do my arrow the other way so I can type. Right, so what this means is graph opens down. That's really necessary here to know. And the function has a turning point of 3, 7, and then it's asking for the range. So I'm going to do a little sketch here, actually, to sort of help me out, see what this looks like. So 3, 7 is somewhere up here is my turning point. And I don't really know what this graph looks like, but I do know that it opens down, which is really helpful to me because now that I can see the graph, I can write the range. Again, we go bottom to top in this case, and we're talking about the y values. So it's going to be -∞ to whatever the y value of the vertex is, which is 7. So here a parabola has two x-intercepts, -5, 0, and 9, 0. So I'm going to plot those, -5, 0, and 9, 0. And then it says, hint, remember, so the question is, what is the equation of the axis of symmetry? So there's a few things that we need to remember. The axis of symmetry is the middle of the x-intercepts. It's a vertical line that cuts the parabola in half. So it takes the form x equals a number. So there's a couple ways you can do this. Honestly, the best way to do this is to find the average between, right? Find the middle. So I'm going to do -5 plus 9 divided by 2 to find out the middle. So that's going to be 4 over 2. So I get 2. So the axis of symmetry is x equals 2. So it's a vertical line, and I'll graph it here, that goes in the middle of the parabola. Right, so I could do a general sketch of the graph. I don't actually know where the turning point is or if this opens up or down, but, oh, that's really bad. But it's going to look something, like this, roughly. It could, or it could go the other way. We don't know. But that's the axis of symmetry. And if you don't trust me, you could count and make sure it's equal distance. So this is 1, 2, 3, 4, 5, 6, 7 spaces here. And then if I go the other way, it should be 7 spaces as well. 1, 2, 3, 4, 5, 6, 7. Yep, so it is an equal distance from both x-intercepts. So I know that that is correct. So that is sort of the first part that you'll see on your quiz. It deals with all the introduction stuff, some vocab, intervals, things like that, and graphs of quadratics. Here's my vote. Chocolate chip cookies over Oreos. Definitely dogs over cats. So there are some pages to remind you of some multiplication rules and vocab, like conjugates and stuff. So here we have multiplying monomials, and it says here, remember when you're multiplying like bases, we add the exponents. So for A, I'm just going to sketch this out. So I'm going to do 3 times 8 and x to the 5th times x squared. And so 3 times 8, 24. X to the 5th x squared is going to be x to the 7th, right? 5 plus 2 is 7. So it's going to be 24x to the 7th. Same strategy in all the other ones. So I'm going to do -2 times -3, which is +6. And then x to the 2 plus 4 is 6. So 6x to the 6th. And we're going to do the next one. So 5 times 2, 10. X squared and x is just x to the 1st. So this is x to the 3rd. And then 3 plus 6 for the y's gets me y to the 9th. And x to the 3rd, y to the 9th. And last but not least, D, we're going to do -4 times 3 is -12. Again, this is x to the 1st and y to the 1st. So it's going to be x to the 3rd and then just a y because there are no other y's. And that's multiplying monomials. Some more multiplying monomials here. Basically, you need to remember what squared means. Squared means multiply by itself. We really need to remember that definition. So here I'm going to do the literal meaning of this. So what this means is -2x to the 3rd y to the 5th squared means you want to do -2x to the 3rd y to the 5th times the same thing. So multiply it by itself. Then that's where I can rearrange if I want. -2 times -2, x to the 3rd times x to the 3rd, and then times y to the 5th times y to the 5th. So multiply, you get 4x to the 6th, y to the 10th. Because -2 times -2 is 4. 3 plus 3 is 6, and 5 plus 5, 10. Right, add those exponents because we're multiplying like bases. So here we've got a monomial times a binomial. The first one should be fairly simple. We're just using the distributive property. You shouldn't even really need to show work there. That would be 8x minus 10. In the second one, so I'm going to show some work. I do suggest that you type your work in the space below, but for right now, I'm just going to do this to show you. So I'm going to do 5x times 3x. So 5 times 3, 15, x times x, x squared. So it's going to be 15x squared, and then 5x times negative 2 is negative 10x, so minus 10x. X times 2x is 2x to the third, 2x squared. And then x times 9 is plus 9x. And then the last one here, we're going to do negative 3x times x squared, which is negative 3x cubed. And then negative 3x times negative 9x is positive 27x squared, because x times x is x squared. So negative 3x to the third plus 27x to the second. So binomial times binomial, bunch of ways that you can do this. If you prefer to use the box method, you can do that outright. I can show you just for the first one, you'd have x, then you'd have plus 8. Oops. Then you would have x and minus 3. And then you would multiply. So x times x, x squared. X times negative 3 is negative 3x. 8 times x is 8x. And then 8 times negative 3, negative 24. Be sure to combine your like terms. So 8x and negative 3x gets me 5x. So I'd end up with x squared plus 5x minus 24. Right, so I just would have to combine 8x. Whoa, yellow, you can't see that. 8x minus 3x is 5x. And then that's how I got to this answer. So the rest of them I'm going to sort of type out just because it's hard to write on this. So here I have this. So I'm going to do 4x times 2x, which is 8x squared. And so I can at least show the foiling, I guess. Right, so I do 4x, 4x times 2x, and then 4x times negative 5. It's going to be negative 20x. And then I'm going to do the negative 9 distributed into the rest of that. So we've got negative 9 times 2x, and then negative 9 times negative 5. That's negative 18x, and then, like I said, negative 9 times negative 5 is 45? Positive 45, not negative 45, because two negatives make a positive. And then combine your like terms, so negative 18x and negative 20x is negative 38x, so we're going to have 8x squared minus 38x plus 45 for B. For C, you're going to do 2x times 4x to get 8x squared again. Ooh, that was kind of an accident. And then 2x times 1, which is plus 2x. And we're going to do negative 7 times 4x, which is negative 28x. and then negative 7 times 1 minus 7. Combine your like terms in the middle. Right, to end up with 8x squared minus 26x minus 7. And then last but not least, I'm going to do 3x times 2x to get 6x squared. And then 3x times 3 to get me 9x. 2 times 2x is 4x. And then 2 times 3, 6. And then combine your like terms in the middle to end up with 6x squared plus 13x plus 6. That's multiplying binomials together, so binomial times a binomial. Squaring binomials, this is really, really important. So this is, again, we have to remember that the squaring means to multiply by itself. And these are not conjugates. They are not the same binomial with different signs. You are multiplying it by itself, so you cannot distribute the squared. You physically need to write out the binomial times itself and then FOIL. Right, so I physically need to do that out. So x times x is x squared. Because if you just distributed, you would miss out on your middle terms if you tried to distribute the squared. So this is going to be x squared plus 5x plus 5x plus 25. Then if I combine like terms, I get plus 10x in the middle. So x squared plus 10x plus 25. And that's the strategy for all of these. So I'm just going to type the answers in. If you want to see them worked out, you can look at the worked out answer key that I am providing. That's in Google Classroom. But for the most part, the strategy is the same here. So this one's going to become x squared minus 14x plus 49. And again, the biggest thing is that you remember to multiply by itself and then FOIL or double distribute or use the box method, whatever you prefer. So 4x times 4x is 16x squared. 4x times negative 11 is negative 44x, and then negative 44x, negative 88x. And then 11 times 11 plus 121. Let me just double check that. Yep, that should be right. And then same thing for this last one. You're going to do 4x plus 3 times 4x plus 3 to end up at 16x squared, because that's 4x times 4x, and then you're going to do 4x times 3, which is 12x, plus 12x plus 24x, plus 9, 3 times 3, 9. Again, if you want to see those all worked out, you can look at the PDF version of the answer key. So now I have conjugates. So remember, conjugates are the same binomial opposite sign. And the nice thing is about conjugates, you can just do the first term times the first term and the last term by the last term. The middle terms will always cancel for conjugates, so that will always work. So x times x, x squared. 8 times negative 8, negative 64. And this will work every time for a conjugate. So x times x, x squared, negative 9 times 9, negative 81. So then for the next one, 2x times 2x is 4x squared, and then 7 times negative 7 is negative 49. So it's going to be 4x squared minus 49. And then last but not least, we've got 4x times 4x, 16x squared, negative y times y, negative y squared. So 16x squared minus y squared. So conjugates should be quick. That's the joy of them. Few more problems here. So when the binomial is multiplied by its conjugate, so the conjugate of this binomial, so we have 5x minus 8, so the conjugate is the same thing, different signs. It's going to be 5x plus 8. And then it wants you to figure that out, multiply it out. So I'm going to do first times first, last times last. So 5x times 5x is 25x squared. And negative 8 times positive 8 is negative 64. So we've got that first choice here. Explain your thinking, right? So I would just kind of explain exactly what I did. The conjugate is 5x plus 8. When I distribute, the middle terms are going to cancel, leaving me with 25x squared minus 64. Pretty straightforward. Some more multiplying binomials. So it says the product of x minus 8, so x minus 8 times something got me x squared minus 6x minus 16. And really, what happens here is, think to yourself, x times what, right? X times something had to equal x squared. The only thing that would work there was x, so this has to be x. And then negative 8 times something had to equal negative 16. So negative 8 times 2, positive 2, so this is going to be x plus 2. And then you could check that by distributing, right? So explaining my answer, I know x times x is x squared. And then negative 8 times positive 2 is negative 16. And if I do out x minus 8 times x plus 2, the middle terms will combine to be negative 6x. And you can kind of prove that here. So, right, if I distribute this, I get x squared plus 2x. And then if I distribute the negative 8, well, I did not mean to erase that. So if I distribute the negative 8, that's going to be negative 8x minus 16. Combine your like terms, and you will end up here. There's a lot going on there. You kind of have to work backwards a little bit to figure out what the answer would be. Few more. So same idea here. 3x minus 5 times something equals 6x squared minus x minus 15. We're going to use the first and the last term to help us. So 3x times something equals 6x squared. and that's going to be times 2x. So automatically I can cross off choice 1 and choice 3. And then -5 times something had to equal -15. And the answer there is +3. So it is going to be choice 2. It's going to say explain my thinking, right? So 3 times 2x gets you 6x squared. And then -5 times 3 is -15. And if I multiply these out, middle terms, 9, -x. And again, you can do that out or look at the answer key. And by multiply these out, if I mean 3x minus 5 and 2x plus 3. So we've got a little bit of a word problem here. So it says a rectangle is formed by increasing one dimension of a square by 3 units while decreasing the other also by 3 units. If the original length of the square is represented by x. So I'm going to draw a square. And it says the original side length of the square is x. So this is x by x because it is a square, so the sides are equal. And then it says we kind of shrink one side and extend the other to make a rectangle. So they say you increase one dimension by 3 units, so that's going to be x plus 3. And then you decrease the other side by 3 units, so it's going to be x minus 3. And then it says which of the following represents the area. So area is length times width. So you're going to multiply x plus 3 and x minus 3. These are conjugates. Since they're conjugates, I can just do x times x, which is x squared, and 3 times -3. Again, I can only do this because they are conjugates. Something like that to explain. And last one. So they basically want you to take this equation and multiply it by x. So we're going to do x times 200 minus 1 over 10x. So if I distribute this, I get 200x minus 1 over 10, and then x times that is x squared. So I believe it is choice 1. And then basically if you distribute, that's what you get. So you can kind of just show the work there or whatever. And that is the answer key in a nutshell. So you have a quiz. I know that says Friday, that's for B-Day. Yours is Thursday, tomorrow. If you have any questions, feel free to ask me.